Okay, thank you for the invitation, giving us the opportunity to present our work here. Welcome to my talk, everybody. So we are just copied actually the title of the whole event. It's about photonic solutions. Disclaimer, you can read that in silence when you download the presentation that will be shared, I've learned afterwards. It's the first time now that I speak to you as a team member of Focuslight. As you all know and recently have heard now, even here in this online meeting, we have joined the Focuslight team. Focuslight has absorbed us. What happens to a particle when it absorbs another particle? It moves to a higher energy level. It becomes excited, and we're all excited. And we're looking forward to our joint future with more energy, obviously. And you can already meet us tomorrow. Several of the participants here are already in Munich. I'm not yet there, but I will be there this evening. And at further presentations, further shows in Shanghai and San Diego. Our vision, let me briefly present the company Focuslight, which may be not so familiar to you. And therefore, I would like to present you some key information. Our vision is to unlock the potential of photonics to enhance and enrich people's life. Some key facts, figures. We have, meanwhile, more than 900 employees in China, in Germany, in Switzerland, and around the world. Invest heavily in R&D, 16% annually. We have lots of patents. If you relate that to the company size, more than 430, and some key facts regarding our clean rooms and facilities. And of course, we are certified in several ISO categories and IATF also. Company is fairly young. It was only established in 2007, so some 16, now 17 years ago. It's headquartered in Xi'an, China. For those who don't know where that is where you find the Terracotta Army. These many very impressive figures that I hope to see soon. We are focused on high power laser, diode, components and materials. So photon generation, laser optics, photon control, and then also photonic application modules, assemblies, subsystems. On the right, you can see the main facilities where we are located, and the corresponding maps down there. So summary: photon generation, photon control, and photonics application solutions. To go a little bit more into detail, what does it mean for automotive? We are featuring products for LiDAR, especially sources in particular, and also for other automotive systems like the driver monitoring system. Here you can see our lineup in laser sources, especially the VCSEL sources, and the corresponding optical elements below. So the collimators, diffusers, homogenizers, and what is coming up, or will be interesting in this presentation, the optics for automotive projection and lighting. And if customers desire, we can of course also offer optical assemblies. Yeah, still core competence, automotive. I don't want to read everything what's here. You can, I'll let you take a brief look here, what we do and what our capabilities are. So we have everything that's needed to generate light, to produce not only lasers, but also full assemblies, modules, testing, of course, also testing for reliability, and also, of course, simulation tools design. Now let's move to microlens. We have heard now today already quite a bit about microlens arrays. I'm still impressed by the presentation of Oliver from Delo with these nice little movies. Why would you use microlens arrays for automotive lighting? There are multiple reasons: styling, size, flexibility, and yes, performance. The typical and first application was here the ground projection that you see on the left picture, but then headlamps came into focus, and as of 2020, now that's already 3.5 years ago, the Lucid Air was termed to have the narrowest headlight aperture of any vehicle to date. I let you challenge this if this is really the case, but this is what I've read in several publications, one of which is listed here. And now we have upcoming new applications also for ground projection, and this could be another potential target to be solved, to be addressed with microlens arrays to support traffic safety, especially the traffic participants around the own vehicle, and also, of course, if that vehicle, if the intention of that vehicle is not very clearly seen. Now, design examples. On the road, you have already seen the Lucid Air, and there will be further models coming up, and the Genesis G90, and you see below the corresponding modules that are in use. On the left, this is a size of roughly 15 by 40 millimeters, and on the right, that is more square, that is something like also 15 by 15 millimeters. So as you can see, very slim features possible with MLAs, and also with some dynamics in the case of the Lucid. But we want to focus for today on our platform that we have started as an attempt to better understand our customers, also to move forward, to try to do also new things. For example, you see here our modular platform for next generation front lighting. And the advantage of having a platform is that enables economics of scale. The previous models were individual elements for individual cars, which carry significant cost and effort and time to be developed, spanning across multiple years. Whereas here, this platform, the mirrorless platform, is readily available. So the NRE is massively reduced. You have a faster time to market. And the advantage is shown, I think, pretty well in this module. You have a reduced integration space. The whole demo is just 50 millimeters thick, and it could be half as thick easily with a different thermal management, because half of the thickness is dedicated to thermal management, not dedicated towards the optical path. And you get the highest degree of customization and freedom of design here. What we do with this platform, we continue the development. It will evolve over time. We do not yet kind of commit to fixed intervals of improvement, but we are continuously working on that. So it's not a one-time shot. It's really to help our customers, to support our customers to finding their own solutions, to have a starting point which is already advanced and which will become even more advanced in the future, so that they kind of can jump from a higher level into their own design adventure with microlens arrays. Here are a little bit more details about this platform. It is suitable for all lighting and signaling applications in the front of the car, and it could even integrate in the future multiple functions within the same light emitting surface. So this is something we also want to bring forward in the future. And on the bottom, you can see one of these modules as we have designed it. But obviously, that is not our core design expertise. And I'm pretty sure many of you in the room could do this much better. There are 3 flavors. Pure means you take what it is, this hexagonal shape. Form, you could come up or ask us request to do your preferred shape, or the full individualization, which essentially means back on track like the previous car models have been done. Here you see some of the design possibilities with mirrorless. And I think I should hurry up a little bit. As a system example, we have here 6 modules for low beam, whereas 4 modules are, that's 6 modules for low and high beam, whereas 4 modules are for low beam, including modules that make a central part of the beam, module that extends the light distribution to the left, another one to the right, and 2 high beam modules. And some simulation results show that you can have, with a spot module alone, you have already a width of the pattern roughly from -25 to +25 degrees. Then if you look at the spread individually, left and right, you see that they are extending this pattern to almost 40 degree plus minus. And if you look at the combined picture, you can also see then the nice low beam distribution. The epic question, and with this I'm coming to the end of my presentation. What can we do for you? We can support in your design activities, fast track development of your own MLA-based headlamp solution. We can support you in modularization in manufacturing, and we can help you to differentiate yourself. And what can you do for us? MLA is a key component in the optical system, but other components are very important as well. We have heard already in the previous talk the role of the LED, and also Daniela's talk about the potential or the request to work on the LED sources to make them better suitable for micro and nano optics. We are interested in learning about new possibilities, new requests. What would you like to see? But also new possibilities, what's possible in prototyping, in miniaturization, in light generation. It's also a very interesting talk from Arthur. We want to hear and we want to learn about styling and solution trends so that we can support our customers better. And we are also interested in benchmarking activities and results. With this, I want to thank you for your attention, and I'm looking forward to hearing your questions. Thank you.